Okay, so I wanted to just make a quick video of a couple of the proofs of the derivatives that we've been talking about lately, because we always run out of time, and I think they're pretty interesting and they're not so hard. So the first one we're going to do is for the log one, because that one's a little bit quicker. And it all comes down to this log rule that I don't think we talked about in pre-calculus, which is called the change of base rule. And this is what it was. This is not the derivative yet. This is just the change of base rule for logarithms. It was saying if you have the log base b of x, you can rewrite that as, you can basically rewrite it with a log with any base. So I could say like log base a of x divided by log base a of b. Or, I don't have to use like log base a, I could use natural log. So I could be like natural log of x over natural log of b. So this is just called the change of base rule. So just as an example of change of base, if I had log base 3 of 5, I could rewrite it with something that I know, like natural log or common log. And this used to be a whole lot more helpful when you had calculators that you couldn't like type in the log base. So the Inspires let you change the base, but most calculators wouldn't. So you would rewrite this as the natural log of 5 divided by the natural log of 3, and then it would become something that you could type in your calculator. So we're going to kind of use this idea to make our derivative proof. Let's say that I wanted to take I wanted to take the derivative of the log base b of x. I could rewrite that as finding the derivative of natural log of x over natural log of b. And actually, the natural log of b is a constant, like natural log of a number. That's just a constant. And so I could rewrite this even further as 1 over the natural log of b times the derivative of the natural log of x, because you can always just pull a constant out in the front. And so 1 over the natural log of b, it's like saying 1/2 or something, is a constant. And so since the derivative of the natural log of x is just 1 over x, I get this, which is 1 over natural log of b times x. And that was the derivative rule. There it is. That is the rule. Proving the rule for exponential functions is a little bit more obscure, but it still is kind of related to log rules and exponential rules. It is all based on this idea right here, that like e to the natural log of x actually just equals x, which I think we've talked about before. I mean, it's kind of like saying, the natural log of e to the x is also x. Like those are really related. They're similar to each other. So if I had e to the natural log of b, that would just be equal to b. So that rule is going to actually help us with finding out the rule for the derivative of b to the x. And again, this is going to seem a little bit obscure, but the first thing I'm going to do is I'm actually going to rewrite b to the x, and I'm actually not going to take the derivative of it yet. Let's just rewrite it. So b to the x is going to be the same thing as e to the natural log of b, because remember that's the same thing as b, all raised to the x power. Okay, so this is the same thing as this, and I'm going to just rewrite that like this. Okay, so now I want to find the derivative of e to the natural log of bx, which remember is the same thing as b to the x, that whole thing is. But I actually kind of know how to deal with e to the x, since the derivative of e to the x is e to the x. This is like a chain rule situation where the e to the power is kind of what I would consider the outside function, and then this whole thing right here is what I would consider the inside of the function. So if I take the derivative of the outside of the function, it's just e to the natural log of b to the x, because remember you have to like leave everything the same, like leave the inside the same. And then I have to do the chain rule, so I'm going to do times the derivative of the circled part up here that I just circled again in yellow, and the derivative of that is going to just be the natural log of b, because natural log of b is a constant, and I would multiply the 1 that's on the x down, and then the x would end up going away. And then remember that this right here is actually the same thing as just b to the x. So if I kind of put that together, I end up getting what my like normal rule looks like, which is the derivative of b to the x is equal to the natural log of b times b to the x. There it is. So now you have the proofs for both exponential functions with any base and logarithms of any base.